In this lesson, we will look at using the JSR 349 with the Spring Framework and Hibernate Validator in our Jakarta Enterprise Edition 8 web application. The JSR 349 is a Java reference specification for validating the elements of your bean. It's also known as the Bean Validation API, and it provides a standard way to define and enforce validation constraints on Java objects. It introduces annotations that can be used to declare validation rules directly within Java classes. An overview of the related Spring Framework, a comprehensive programming and configuration model for modern Java-based enterprise application. In the context of Bean validation, Spring provides integration with the Bean Validation API, allowing you to easily apply validation rules to Spring-managed beans. Spring's validation support includes validation annotations for Spring MVC controllers and methods, as well as support for declarative validation using the add_validated annotation. The Hibernate Validator is the reference implementation of the Bean Validation API. It extends the basic validation capabilities provided by the Bean Validation API with additional features and constraints. The Hibernate Validator integrates seamlessly with popular frameworks like Spring to provide powerful and flexible validation capabilities, and it supports both method validation and validation of domain objects by automatically validating constraints defined using annotations such as not null, @size, @email, etc. And now it's time to go to our course documentation. We'll go down to Spring Framework Enterprise Development. In here we select using JSR 349. And first we will look at what is Bean validation in the context of Java Enterprise Edition and the Spring Framework. Bean validation is a mechanism for validating data within Java beans or POJOs. It is a declarative way to express validation constraints on the fields of your beans. Bean validation works through annotations. You can place them on fields, getter methods, or on the class level, and it defines the constraints that the data must satisfy. Some examples specifies that a value cannot be null, size, the size constraints on a string, collection, or array, pattern, specifies the regular expression pattern that the value must match, the minimum and maximum values for numeric fields, an email, well-formed email address. When you use Bean validation, you can define these constraints directly on your bean classes. When you pass instances of these beans to the validation framework, it automatically validates them according to the constraints you've defined. For example, a user class with fields like username, email, and password. This is where you will use validation annotation to ensure that these fields meet certain criteria, such as not being empty, being a valid email, and having a password of a certain length or pattern. Bean validation is useful in web application for validating user input before processing it further. It helps to ensure data integrity and maintain consistency in your application. It also promotes cleaner code by centralizing all your validation logic and making it easier to understand and maintain. Now back to our overview, and we'll select why use Hibernate Validator with Spring 5, because it offers several advantages. First is compatibility. Hibernate Validator is the reference implementation of the Bean Validation API, and it integrates seamlessly with the Spring framework, and it ensures smooth interoperability and compatibility between Spring's validation mechanisms and the Bean Validation API. Robustness and maturity. Hibernate Validator is a mature and widely used validation framework. It has been developed and maintained for many years, accumulating a wealth of features, bug fixes, and optimizations. It's a reliable choice for handling validation requirements in Spring application. Third, it's feature-rich. A rich set of built-in validation constraints and annotation covering a wide range of common validation scenarios. It supports complex validation rules such as conditional validation, cross-field validation, and custom validation constraints. Fourth, extensibility. It allows for the creation of custom validation constraints and validators, enabling developers to tailor validation logic to their specific application requirement. It's very useful when dealing with domain-specific validation rules or integrating third-party libraries. And the last point, community support. Being a widely adopted validation framework, Hibernate Validator benefits from a large and active community of users and contributors, regular updates, documentation, and improvement, and a wealth of resources available to developers. So while the Spring framework provides its own validation support through the add-validated annotation and the validator interface, Hibernate Validator complements Spring validation capabilities by offering a standardized and feature-rich implementation of the Bean Validation API. This combination allows developers to leverage the strength of both frameworks effectively. Now back to the overview, and we are going to look at how to configure Hibernate Bean Validation in a Spring 5 MVC Service Layer Jakarta Enterprise Edition 8 web application. So 5 basic steps. First, add the dependencies to your Maven or Gradle build file for the Hibernate Validator. Second, you enable validation in Spring in your Spring configuration class by adding the @enable validation annotation. If you are using XML-based configuration, you can configure it in your Spring XML configuration file. Then you configure your validator. Spring supplies you automatically with a local validator factory bean, which acts as a bridge between Spring's validation facilities and the Hibernate Validator. You can inject this bean wherever validation is needed in your application. Then you apply the validation annotations like @NotNull to your domain model classes or data transfer objects. These annotations define the validation constraints for the corresponding fields. Step number 5, you validate input in the controller. In your Spring MVC controllers, you use the @valid annotation on method parameters, or you use method level annotation like request body to trigger validation on incoming data. This will automatically validate the input against the constraints defined in your domain module. Number 6, you handle validation errors. Spring MVC provides mechanisms to handle the errors gracefully. You can use binding result or the error objects to access validation errors and perform appropriate error handling, such as returning error responses or redirecting to error pages. And step 7, you integrate with the service layer. Your service layer can interact with validated data passed from the controller. You can ensure that validation is applied at appropriate points in your service methods, especially when accepting input from external sources. And now we look at a simple example. We have the app config, which is automatically configured in Spring with configuration and at enable validation. Then we have a REST controller with a mapping of API/users. And in here we have the user controller class with the auto-wired user service. Then we have a post mapping for create user. And here we have the add valid request body on the user data transfer object with the binding result. And if result has errors, return the response entity bad request and the body and say validation failed. If there's no errors, call the create user with the user data transfer object on the user service, and then return the response entity OK. And here is the user service with the auto-wired user repository, create user with the user PO, our business logic, and our user repository saved. User DTO is a data transfer object representing user input, and it's annotated with validation constraints. The create user method in the controller validates the incoming user DTO object using add valid, and any validation errors are captured in the binding result. Finally, the validated data is passed to the service layer for further processing. Now, next up, we look at how to configure the Spring Validator bean, a custom Spring Validator bean to handle validation beyond what Hibernate Validator provides. This allows you to add custom validation logic or to integrate with other validation frameworks if needed. Here's how to configure the Spring Validator bean. We create a validator implementation by implementing the validator interface provided by Spring. This interface has a single method, validate the target object and the errors that you need to implement. And inside this method, we perform custom validation logic and any validation errors to the error object. Here is the support override, and here is the validate override, where we put in our custom validation. Then we return the error reject value on the custom validation for the field name, the error code. Second, we configure the validator bean. We register the custom validator bean using @bean annotation or @component scan. We configure the validation bean. In our Spring configuration class, we register the custom validator using @bean annotation or @component scan if it's a package scanned by Spring. Here's our app config. Here we return the new custom validator bean. Then we integrate with Spring MVC by using the custom validator in our Spring MVC controllers. And this we do by injecting and adding it to the init binder method or as a method parameter annotated with @validated. Another REST controller with a request mapping, auto-wiring the custom validator, adding it through the init binder method, and on the post mapping endpoint is specified @validator and the binding results. We code our validation errors and we return the bad request body on validation failed. And if there's no errors, we return the OK. With this setup, Spring will automatically invoke both Hibernate Validator and your custom validator during data binding and validation. This allows you to have a unified validation mechanism that combines both built-in and custom validation logic in your Spring MVC application. And now we are going to look at error code localization. And since we already covered localization, this should be an easier concept to grasp. You use a message source and a resource bundle for managing localized error messages. First, you create the properties file containing your error message for each supported locale. Names like message.properties, and then for each country or region, message_locale. Here is an example of the standard English error codes, and here is the corresponding example of the French error codes. Then you configure the message source bean, and you do that in your Spring configuration class. Here is the message source bean, new reloadable resource bundle message source, your base name, your default encoding. Number 3, you configure Hibernate Validator to use Spring message source by creating a custom local validator factory bean. It extends the local validator factory bean. You auto-wire the message source, and after properties set, you set your validation message source. Step number 4, you use a custom validator factory bean registered in your Spring configuration class. In your app config, you specify @bean, you return the new custom validator factory bean. With these configurations in place, Hibernate Validator will use the Spring message source to resolve error messages, allowing for error code localization based on the user's locale preferences. When a validation error occurs, Hibernate Validator will search for error messages in the appropriate message properties file based on the locale set in the application context. This provides a seamless integration of error code localization with Spring MVC and Hibernate Validator in your application. Now back to our overview, and we will look at how to add constraint validations to our beans. This involves annotating your bean properties or methods with validation constraints provided by the Bean Validation API. Of course, first you'll add the dependencies, then you annotate your bean properties with validation constraints according to your requirements. You use the annotation to indicate the constraint of strings, such as your username not null, and specifying your password as not null with a size minimum of 6 and maximum of 20 characters. You can also apply the constraints to method parameters by annotating method parameters with validation constraints. For instance, in this method, you specify the input not empty of the username and password. You can also add class level constraints like validated or valid. These annotations can trigger validation on nested objects or validate object graphs. So here is an add valid on a customer. You can also customize your constraints by providing additional attributes to constraint annotations. For example, you can specify message templates, groups, or payload information. So here you specify a minimum value with a message. You can also use group sequences to specify the order in which validation groups are executed. So here is a group sequence with a basic info validation class and a complete info validation class. With these annotations in place, when you pass instances of these beans to the validation framework, the framework automatically validates them against the constraints you've defined. If any validation constraint is violated, appropriate validation error messages will be generated. Here we look at commonly used built-in constraint annotations. This is not null, can be applied to fields and method parameters and method return values. This is not empty. This is for collections, arrays, and maps. This is not blank. String must not be null and must contain at least one non-white space character. There is size. This specifies the size constraints for strings, collections, arrays, or maps. Then we have admin and admax, minimum age of 18. Then we have the @email, specifies a well-formed email address. Then we have the regular expression pattern that the annotated string must match. So here we specify an alphanumeric username. So this is just some examples of the built-in constraint annotations provided by the Bean Validation API. You can also implement the Constraint Validator interface. And here is more examples of a user administrator POJO. Username not blank, message not blank, minimum, message invalid email address. In this example, the user administrator class has constraints applied to its username, password, and email, using annotations such as not blank, size, and email. Another example of the registered charity POJO, all the annotations. Here, the registered charity class has constraint applied to its name and registration number fields. The name field cannot be blank, while the registration number field must be exactly 9 characters long, containing only digits. These constraints ensure that instances of user administrator and registered charity meet certain validation criteria. In a web application, you can then use these POJOs for forms or API requests, validating the input data against these constraints to ensure data integrity and consistency. Using add_valid for recursive validation allows you to trigger validation on nested objects or object graphs. This is useful when your object contains other objects that also need to be validated. Here's how you can use add_valid for recursive validation. This is the valid on the customer inside the order. This is adding the validated annotation on the order, and this is how you trigger the validation controller in your service layer using add_valid on method level annotation. REST controller validated, post mapping orders, create order, add_valid request body order, and return response entity OK. In this example, when a post request is made to the orders endpoint with JSON representing an order object in the request body, Spring MVC automatically validates the order objects and its nested customer object recursively. Using @valid for recursive validation helps ensure that all nested objects within an object graph are validated according to their respective constraints, providing comprehensive validation coverage of complex data structures. Validation groups allow you to group validation constraints and selectively validate certain groups of constraints based on your application's need. This is particularly useful when you want to apply different validation rules to the same object in different contexts. Here's how you can use validation groups. First, you define the validation groups by defining custom marker interfaces to represent your validation groups. These interfaces can be empty and they serve as markers to group validation constraints. So here we have a basic validation interface. Here we have a complete info validation interface. Then we apply the validation constraints to group. You annotate your fields or methods with the desired validation constraints and specify the validation groups they belong to. So the username falls under basic info validation. The password falls under complete info validation, as well as the email. Then step 3, you trigger validation for specific groups in your controller or service layer by specifying the validation groups to validate against when triggering validation. So here is a REST controller with @validated and a post mapping of user, and @validated basic info validation on the user. And here is users complete with @validated complete info validation class. So now you can decide whether you want basic validation or complete validation. So the create user method only triggers validation for the basic validation group, while the create user complete info method triggers a validation for the complete info validation group. Using validation groups allow you to define multiple sets of validation rules for the same object and apply them selectively based on the context in which validation is performed. This provides flexibility and granularity in managing validation constraints in your application. Now the last section. Checking constraint legality at compile time involves using compile time annotations and static code analysis tools to ensure that constraints are applied correctly and consistently throughout your code base. So we look at some approaches. First, custom annotations with annotation processor. You use annotation processors to validate the usage of these annotations at compile time. These annotation processors can analyze your source code and generate compilation errors or warnings if constraints are violated. Then you can use static analysis tools such as check style, PMD, or find bugs. This will enforce coding standard and best practices, including constraint legality. These tools can be configured to flag violations of constraint usage rules and conventions during the build process. Then you can enforce custom code lines and established reviews within your organizations to ensure compliance. Then you can also use continuous integration checks, where you integrate your constraint legality checked into your continuous integration pipeline to catch violations early in the development process. Then there is also IDE support for compile time checks, of annotations and coding standards. Then you can also use built-in Java annotations wherever possible, leveraging the annotations and their associated compiler checks for common constraints such as override or deprecate or suppress warnings. So by combining these approaches, you can ensure that constraint legality is verified at compile time, reducing the likelihood of runtime errors and improving code quality and maintainability. And now we're finally ready to go over to Eclipse, and we look at our POM file, and we see we've added the Hibernate Validator dependency and the Bean Validation API dependency. The next step, according to our course documentation, is to configure the validation. So we start at the bottom of our validation with the Bootstrap, and it's a web application initializer, and we see we get a root context, and we also get a servlet context. So right here there are no configuration required for Spring validation, but let's go a level up to the root context configuration, and here we see a local validator factory bean that sets a validator, and we see validation path added for the methods. A validator is added here, and it is set to validate the incoming messages. And from our previous Bootstrap, it is the root context configuration. So everything that goes through our services will go through this validator. Then we go one level up to the servlet context configuration, and we see we've injected the Spring Validator adapter, the validator, and we've overwritten the get validator to return the validator. The rest of the class pretty much stays the same. Now that we've configured our validation, we can apply the validation constraints. We have a user admin repository, and we don't see any validation constraints. We have the user admin principal, and in here we don't see any constraints. We have the temporary authentication service, and here we see some checks, but it's still not decorated with annotation. Next, we look at the user object, and we see the user object is not annotated. So now we look at the authenticate service, and here we see our first authentication annotations, not blank, and it returns the localized message of validate authenticate username, and the same for password, specifies at not blank. Then we look at the authentication controller. It injects the authentication service, and here at the post mapping login we see a annotation of valid login form, and we also see the Spring Framework validation errors being passed in. So here it's calling the authentication service with the username and password, and if there is a constraint validation exception, it adds the validation errors to the model and returns the model. If everything is successful, it sets the principal along with the session, and it continues on to the charity registration part of the web app. Then we look at our login form, and here in the login form we see we also have the not blank message associations for username and password. We have the login JSP, and we import the validation errors. Here we've added a message of the error login, and here we go through and list all the validation errors. And inside the post method, we've added the errors class, form errors and form errors, which means if everything works as it should, we should be able to catch a login error when the username or the password has not been filled in. So now let's run our code and look at the validation in action. Run as, run on server, select localhost A, finish. And here is our login page. So let's see what happens. And the validation error shows up. Username and password is required. Let's try and log in with an invalid username and password. And we see with the invalid username and password, we also have the old error, but we did not use the new way of validation. And finally, let's use a correct username and password. And here we are logged in. Now the example code has added validation to the registration, and I'll leave it for self-study to look at the other example code and to add validation to all these menu options on the left using the course documentation and the given GitHub branch. And that concludes this tutorial. I will see you in the next one.